Hi everyone, this is me again, Bobby Figueroa, your faculty in charge of ComSci 201, and this is the ComSci 201 lecture series. This is session number 3, and we're still talking about propositional logic, which is in module 1. So for this session, we will be talking about propositional logic syntax, items which are the symbols, and the operators or connectives of propositional logic, and we will also be talking about precedence rules. So what is propositional logic syntax? Syntax deals with symbols and rules for representing propositions. It is also what describes or dictates the structure or form of a sentence. A sentence can be one proposition with a unary operator or a unary connective, and it can also be two or more propositions that are joined by operators, an operator or a connective. So here are the logical connectives or logical operators in propositional logic. The first one is not, which is a unary operator or connective. The rest are binary connectives. That'll be and, or, if, then, and if and only if. So this is how we can describe them. So all throughout this section or this module, we will be dealing with a lot of symbols. So now we will be defining these symbols so that in the future you will be able to reference them here. The first is T and F, which stand for true and false, respectively. They are the truth values of a certain proposition or a certain set of propositions. Uppercase letters denote propositions, so sometimes they can have subscripts, but most of the time they won't have subscripts. So common examples of proposition symbols are capital P, capital Q, and capital R, but you can use any letter that you like. The next would be the connectives, not, and, or, implication, or if and only if, respectively. We also use script uppercase letters for sentences. So the usual script capital letters are F, G, H, and those with subscripts. So let's define a few terms before we move on. First, again, syntax. Syntax is about usage, and it tells you how to construct simple and compound propositions or sentences. Verbal form refers to the sentence or compound proposition formed in words. The equivalent term is the name of the compound or proposition formed. And finally, there will be some keywords that we will be using to aid you in converting English sentences into compound propositions or propositional sentences. Here is the transformation guide for the different symbols and how they will be written or how they are supposed to be written. So this is a syntax guide for each connective. The first connective that we will be talking about is not. And the symbol for not is a tilde. And if you combine a tilde and a propositional symbol, then that means not P. The equivalent term for not P is a negation. The next connective is and the symbol for and is usually the caret in the keyboard, and the syntax is a proposition P and another proposition Q. So this is how you read it, P and Q. And the equivalent term is a conjunction. It is also called a conjunction. The next is or, whose symbol is somewhat like a V. And the way you use or is you connect two prepositions P and Q with it, with an or. And it is read as P or Q. The equivalent term for or is disjunction. The next is if then. This arrow sign to the right is the symbol for if then, and P, or if P then Q, is how you write it. It is read as if P then Q. The equivalent term for that is implication or conditional. The next one is if and only if. The symbol is a double-headed arrow, and the syntax is a preposition P, the double-headed arrow, and then Q. So you read it as P, if and only if Q. It is called equivalence or biconditional equivalence. Some of you have been also asking about other connectives such as reduction and XOR. These are also valid connectives, but for the purpose of simplicity, we don't teach them here because they're not really commonly used. Also, they can be replaced or they can be represented by any or by one of these connectives. For example, reduction is just the reverse of if then. So a reduction like P reduction Q can be represented by Q implication P, or Q implies P. So we don't really have to memorize reduction because it can be represented by an implication like this. How about XOR? XOR is exclusive OR. It can be represented by or and and. It's actually P or Q and not P and Q. So that is XOR. Anyway, if you want to talk to me about it, about the proof, you can do so via sending personal messages to me, and we can talk about it. But for the others, you don't really have to think about it right now. The most important thing is you know these 5 basic connectives: not, and, if then, and if and only if. So here are the other keywords that you can take note of. Of course, there are keywords that are already used for each connective, but here are other keywords that can guide you in transforming an English sentence into a prepositional set of symbols. So, for example, not can be not P. It can also be the denial of P, or it is not the case that P. For and, of course, the most common keyword is and, P and Q, right? But it can also be represented by both P and Q, P but Q, Q but P, P while Q, and Q while P. For or, it can be represented by either P or Q, aside from P or Q, and at least one of P, Q, R, etc. For implication, for if then, aside from if P then Q, it can also be represented by P only if Q, Q if P, Q when P then Q, Q provided that P is a sufficient condition for Q, and Q is a necessary condition for P. So you should take note of these keywords so that you can transform English sentences correctly into their symbolic form. Then the last would be if and only if, and it's pretty simple. P is equivalent to Q. That's aside from P if and only if Q. I hope these are clear to you. So just in case, let me give you an example. Here is a table of symbols and their English sentence equivalents. Let P represent 1 plus 1 equals 2. Let Q represent Magellan killed Lapu-Lapu. And let R represent it is raining today. So let's look at the following sentences. The first is, it is not raining today. Since it is raining today is represented by R, and this is actually a negation of that sentence or of that preposition, then we write down not R. Next, 1 plus 1 equals 2, and it is not raining today. So we just substitute this with P, and then use AND, which joins P with not R, representing it is not raining today. Next, either it is raining today or 1 plus 1 equals 2. It is represented by R or P. The fourth example is, neither is it raining today, nor 1 plus 1 is equal to 2. It can simply be represented by a negation of R or P. Take note, you have to group R or P first and then negate them. This is never equivalent to not R or not P. That's wrong. So you should put R or P first, group them together, and then put the negation symbol. It means that it is not the case, that it is raining today or 1 plus 1 is equal to 2. So those statements are equivalent. Is that clear? If not, then you can give me a private message and we can talk about it in detail. Later on in our equivalence class, in the class that will be dealing with equivalence rules, we will be able to prove this easily. But for now, you have to accept that this is the representation for neither is it raining today, nor 1 plus 1 is equal to 2. Okay, next. If Magellan killed Lapu-Lapu, then it is raining today. It is easily represented by Q, then R. Or if Q, then R. Next, Magellan killed Lapu-Lapu if it is raining today. So here the condition is it is raining today, so it is if R, then Q. Now, you might notice in this example that only if behaves differently than if in this example, right? This is because only if means something different than if. Only if makes the preceding statement as a necessary condition, whereas if makes the preceding or the succeeding proposition into a sufficient condition. And the pattern for a sufficient condition is that it should be the premise and the consequent or the consequence should be this one. For a necessary condition, the premise should be this, and the condition itself will be the consequence. So you have to take note of this rule. Again, for if, it should be the premise. If it is raining today, it will be the premise. And Magellan killed Lapu-Lapu will be the consequence. For only if, Magellan killed Lapu-Lapu will be the premise, and it is raining today will be the consequence. I hope that's clear. Now, if you want a detailed proof, maybe I can explain it better in Filipino. We can have a class together before the exam so that we can prove it, or you can also talk to me or to your tutor, Sir Junjun, about it. and we can help you be convinced that only if is different from if. Okay, next. Magellan killed Lapu-Lapu if and only if it is raining today. It is very easy to convert. Q, if and only if R. So those are the examples. Now before we end, I want you to understand the concept of precedence or precedence rules. So these rules dictate the order in which evaluation should be done. A precedence rule also dictates grouping in the absence of parentheses by assigning different priority levels to operators or connectives. So here they are. As you can see, I have priority levels 5, 4, 3, 2, 1. The higher the number, the higher the priority level. So the highest priority level is not, the not connective. Next would be and. So take note that and is higher than or, and or is higher than if, then. Finally, the lowest in terms of priority level is if and only if. So here are some examples. As you can see, I've colored the parentheses differently for certain groupings so that it'll be easier for you to understand the groupings. So here's the first example without grouping. P if and only if Q implies R and S or U. So for that, we will first find a negation. We can see a negation or a not. So let's look for an and here, a conjunction. So now that we see a conjunction, we will group R and S together. And then let's find a disjunction. Now that we see a disjunction, we will group the symbols together with another set of parentheses. So R and S or U. This is the second grouping. The third grouping will be in this implication. So this will be Q implies R and S or U. And they will be grouped by this pair of parentheses. And then we don't need parentheses for this. P if and only if, and then this group. So we can read it as P if and only if Q implies R and S or U. Now let's see this example, which is from the book. It's not P or Q and R implies S implies U. So let's first look for a negation. We saw a negation here, not P. So we can parenthesize that. It's up to you. Sometimes some people don't use parentheses for a unary operator or a unary connective. But for myself, just to be clear, I wanted to use parentheses, so I used parentheses here. It's up to you. So not P, and then we'll look for an and. So here we found an and, so we will put a set or a pair of parentheses, Q and R, and then we will try to find an or, and we found it here. So it's not P or Q and R. And then we will try to find an implication. We found two implications, so what will we do? We will go from left to right. So the priority will be this one, this first implication here, and then this one. So we will apply the first grouping, this green set of parentheses. So it will be not P or Q and R implies S, and then implies U. So that's how you apply the precedence rule. This might not be, or this might not look important to you right now, but later on when we discuss semantics, it will be very, very important. So please take note of these precedence rules. Now let's look at SAQ 1-2. In future SAQs, I will not be helping you answer the questions, but because we've been encountering errors, I want to make sure that you understand the foundations or the foundational topics first. That is why I will be helping you answer the SAQs for now, but in future modules, I will have you answer them yourselves. Okay, so here's the direction. Translate the following English sentences into symbols in propositional logic. Write your answers in the box provided across each sentence. So let S, W, and G be the following propositions. S means I will study discrete structures. W means I will watch a movie. And let G stand for I am in a good mood. Okay, now let's try to do the conversion. First is, if I am not in a good mood, then I will not study discrete structures and watch a movie. So let's try to find I am in a good mood. That's G. And since it is negated, we will say that it's not G. We can see the keyword if. So if I am not in a good mood should be not G, implies. Then we see the keyword then. So after the keyword then, we will look at the next propositions. I will not study discrete structures. It is the negation of S. So it's not S. And watch a movie. So we will use a conjunction. Not S and W. And since it succeeds the keyword then it will be at the right side of the implication symbol. So not G implies not S and W. Next example. I will not watch a movie and I will study discrete structures. So it's pretty simple. I will not watch a movie is just a negation of W and an affirmation of I will study discrete structures. So it's just an S. So it's not W and S. The third example, I will watch a movie only if I will not study discrete structures or I am not in a good mood. So first is I will watch a movie, so that's W. And then we can see this keyword only if. We know that only if will be succeeded by a necessary condition. And if it's a necessary condition, then it will become the consequence. So the consequence will be at the right side of the implication, and we can now convert them into symbols. I will not study discrete structures is a negation of S, and then we put an or a disjunction. I am not in a good mood is another negation of G. So W implies not S or not G. Finally, we have I am in a good mood if I will neither study discrete structures nor watch a movie. So as you can see, if here is succeeded by a sufficient condition. So if it's a sufficient condition, then it will become the premise. So we have to evaluate the premise first, which is I will neither study discrete structures nor watch a movie. Do you remember how we evaluate neither nor? We first use a disjunction and connect S, which is study discrete structures, and W, which is watch a movie, or I will watch a movie. So it should be S or W. Now that it's neither nor, then we negate the whole statement or the whole disjunction. So it's not parenthesis, S or W parenthesis. And then we will convert this proposition to become the consequence. I am in a good mood, which is simply G. So it's not S or W implies G. So that's the answer to the last item. Okay, so I hope that everything is clear to you. You can always ask me or Surgeon June, preferably Surgeon June. He will be very happy to reply to you since I will be focusing on developing more videos for you so that you can understand the material better. Some announcements before we end. We have another list of corrections, so you just visit the folder that contains the list of corrections. This particular list of correction is more updated. It's from the previous teacher of this course, which is Mr. Virai. And then I've also uploaded the video for giving instructions on how to register in Academiacs using your UPOU or UPID. And I want you to also watch the welcoming remarks of the CEO of Academiacs, which has chosen us to be pilot students and teachers of their platform. And that's Joan Kincaid. If you have any questions, again, email me or Surgeon Ju. See you again next session. Bye.